Day. Night. Based on the lights outside, I want to switch on my room's light automatically. I heard Arduino can do it. Combined with a sensor. Let us get to work, right away. Instead of spending money to buy the hardware, I tried to simulate it using Tinkercad. And in just 2 minutes I have an Arduino, a sensor and a light. If you look carefully here, it is written analog, and here digital. So the analog device should be plugged in here. Which one is the analog device? Sensor, of course. And then the digital device, which is the light, here. To work on an Arduino without buying it, we will use Tinkercad. Like this, we will go to the site and here, we will create a Tinkercad account. Here you can find all the components and you will be assembling them here. Let us drag the Arduino board, LED, and the sensor module from here to here and connect them like this. As you can see, Arduino has an input part and an output part. Wait, isn't it like a PC? An input device, output device and a processing unit. Yes, but not as efficient as a PC. A PC has multiple sets of microcontrollers and can do multiple tasks at a time, whereas an Arduino has only one microcontroller and can do only one task at a time. What if we add multiple microprocessors to the Arduino? One example of that would be Raspberry Pi. It has the same input-output pins like the Arduino but can do multitasking like a PC. So this is how it works. We have an analog port that receives values and we do some processing or coding and then give feedback to a digital port. Let us look at the interesting coding section now. Clicking here takes us to the coding window. We have global variables and a setup function like the main function in C++. And then a loop function which will be running continuously in a loop. So that we can keep monitoring our A0 analog port, and if there is a value then we can make the digital port D13 react. Now this is the real code. A0 is for analog port. This pin mode 13 is for digital pin 13 as output. This is a standard value and it means 9600 bits per second data transfer rate. And then we have our continuous loop. First we read the sensor pin. If the sensor value is less than 600 then it is night and the light needs to be turned on and vice versa. The loop executes very fast, so it is common to see a delay function. In our case though, the delay does not matter. And that is it. We finished coding. To make it work we need to do one more thing. Light is connected this way with a resistor. Sensor this way. We can now plug this and see how it works. And then I purchased an Arduino and it worked exactly the same. But in some cases I wasn't sure of the resistor I needed to buy or the resistance value. For example, if we remove the resistor here it will show a warning. So this tool really helps us to try out resistors that are available at an online shop before purchasing them. Like this, I learned how to build my smart light from scratch using Arduino and Tinkercad, and so did you.